Thermo-Calc software can be used to calculate phase equilibria, phase transformation temperatures, and thermodynamic properties for welding and joining applications using the step and map options in Thermo-Calc. DICTRA can be used to model the kinetics of diffusion-controlled phase transformations as well. For non-equilibrium solidification, one can use the Scheil solidification simulation calculator to calculate the fraction solid curve as a function of cooling, incipient melt temperature, latent heat during cooling, and microsegregation during solidification. In this video, I'll show you one such calculation, a Scheil solidification simulation based on the austenitic stainless steel 188. You can follow along with this example by downloading the free demo version of Thermo-Calc software. Simply click the link currently on your screen or visit our website. Then come back to this video once you have installed the demo software. From the home screen of Thermo-Calc, click on the Scheil solidification simulation template. All the nodes we need to complete the calculation will appear in the project pane. Select the System Definer, where we'll select our database and elements. From the Database drop-down menu, select the FE Demo database, then select the elements iron, chromium, and nickel. The actual austenitic stainless steel 188 also contains carbon and manganese, but the demo version of our software is restricted to 3 elements because it is for demonstration purposes only, so we'll be looking at a modified alloy. Next, we'll set the composition. Iron will be dependent, so we'll let that set automatically. From the top, chromium is 18 and nickel is 8. This sets iron to 74 mass %. Our system is now defined, so select the Scheil calculator node where you configure the calculation. Here we can change, for instance, the temperature and temperature units. We can choose to use global minimization, and we can select which phase is identified as liquid. Notice that our composition auto-populated here as well. We'll use the default values, so we don't need to change anything in this node. Our calculation is now set, so click Perform Tree at the bottom center of the program. Once the calculation is complete, a plot will appear in the results pane. In this plot, the solid line shows you at what temperature various phases form. If you zoom in, you can see the line more clearly, and the key will tell you which phases are present in the colors currently on the screen. For instance, the red line shows us that between approximately 1455 degrees and just below 1480 degrees, BCC A2 is forming. The dotted line represents equilibrium. We can see that below about 1475 degrees, the two lines diverge, which is due to microsegregation. The x-axis shows the total fraction of solids from all phases at each temperature. For instance, the rightmost end of the graph is entirely solid, and the leftmost side of the graph is entirely liquid. If you hover your mouse anywhere on the line, you will also see this information. For example, we can see that at about 1475 degrees, the mole fraction of solid is approximately 0.26, or 26%. Starting with Thermo-Calc 2015b, the Scheil module also allows you to view the results in the form of a table. Right-click on the Scheil calculator node, hover over Create New Successor, and select Table Renderer. Then right-click on the Table Renderer node and select Perform Now. Once the calculation is complete, your table will appear in the results pane alongside the plot. The table contains the same information as the plot. For instance, if we look at approximately 1475 degrees, we see the same results we saw when we looked at the plot, a mole fraction of solid of approximately 0.26. We hope you found this video helpful. We're constantly working to create new videos, so check back regularly at www.thermocalc.com.